Okay, let's look at rates of change in context. And when you find answers to word problems where you have to use a derivative, you very frequently on the AP Calculus exam have to interpret that answer in the context of the problem. And that's what we are going to look at here. And the main ideas to remember when you are interpreting derivative type answers is that if a derivative is positive, the function increases, and if a derivative is negative, then that function decreases. And that will be basically how you interpret your questions. Don't try to overcomplicate it. Keep it as simple as that. Derivative positive, function increases. Derivative negative, function decreases. So here is one example. We will use a calculator on this one. You have a function, fairly ugly, that represents the number of birds on an island, t years after the year 2000. We are to find b prime of 7 and use correct units to interpret that answer. So if it is a calculator active question, which I am declaring this calculator active, you are expected to use a derivative at a point command. You don't have to show any work that led to the value of b prime of 7. They expect you to punch it straight in the calculator. So I am using a TI Inspire, and I start by storing my function in F1, double checking that I entered it correctly. Then on my calculator screen, I will go Menu, Calculus, Derivative at a point, and when you select that, it will ask you what variable you want to use. I usually just stick with X. You can change it to T if you would like. I'm going to plug in the value of 7 to the first derivative. If you do have to evaluate the second derivative or something else, then you can choose that from the drop-down menu, but we will go first derivative. Okay. Pops up a template, and here it asks you to simply fill in the blank for the function. And because I have this function stored for f1, I will tell the calculator to find the derivative of f1 of x, then plug in 7. I'm in the habit of hitting Control Enter to force the decimal, so I do that, and I get an answer of 16.0769 and a bunch of other garbage. So I'm going to grab that and put it on my workspace. So save to current page, and here it is. So now we have our value, and we have to interpret that value. First, I'm going to write this down accurate to 3 decimal places. So this happens at b prime of 7 is, I guess I'll say, is equal to, and on the AP Calculus exam you must be accurate to that third decimal. So in this case we have two options. We can follow standard rounding procedures, is 0.0769, so I round the 6 up to a 7, or they will accept something called the truncated version, which is when you simply quit writing after the third decimal. I go back and forth. Sometimes I'll do the truncated. Okay, and I was just interrupted by an announcement, so I'll pause the video, and I don't remember what I was saying, but you can truncate or you can round to 3 decimals. So here we have our answer, and then we are to interpret this in the context of the problem, and this is where you want to keep things simple. We found the value of a derivative, and we found out that we got a positive result. B prime of 7 is positive. Therefore, my thought process is that my function b is increasing. That is going to be how we interpret this answer. But that's just kind of a basic thought process. That's not our answer, because that doesn't tell you anything about the context of the problem. If I go to somebody and say, hey, b is increasing, they wouldn't know what I'm talking about. So instead of saying b is increasing, I will, in words, describe the function b, and b is described as the number of birds on an island t years after the year 2000. So instead of saying b is increasing, I'm going to say the number of birds on the island is increasing. Okay, so there's my first interpretation. And then when you interpret in the context of the problem, you want to restate all values that are involved in the solution. And in this case, I need to restate the value of 16.077. I need to attach correct units, and then I need to restate that this is happening when t is equal to 7. So the number of birds on the island is increasing at my answer of 16.077, and that will be in units of birds per year. So increasing at that rate when, and you can answer the next part in 2 different ways. When t is equal to 7, or you could say, or in the year, what was this, t years after 2000, so in the year 2007. So you could answer the time component in two different ways, but you do need to restate the time that was used, the answer that you got, make sure you include units, and then just keep it simple. Function is increasing, function is decreasing. Look at another example. This time we have a function d of t that represents the depth of water in a pool. It is being drained to clean, and it says use correct units to interpret the meaning of d prime of 35 as negative 0.72, and we're interpreting that in the context of the problem. So again, I have a derivative. The value of that derivative is negative, so my thought process is that d is decreasing. And that's where I'm going to start. That's where my brain begins. And that is true. D is decreasing because d prime is negative, but then I have to describe in words what the function d is, and d is the depth of water in a pool. So I'm going to start by interpreting this by saying the depth of the water in the pool, so that's just a big wordy description of d, is decreasing. And then again, we need to restate all numbers that are in the problem. That would be the time of 35 and the unit, or the value of negative 0.72. So decreasing. Okay, now here's where you have to be careful. When something is decreasing, the word decreasing already implies a negative in the problem. And so I'm not going to say decreasing at negative 0.072, excuse me, negative 0.72. But because the decreasing is already taking care of the negative, we will say the depth of the water is decreasing at 0.72. And so decreasing at 0.72 units would be, let's see, the depth is measured in feet and t is measured in minutes. So my unit of change would be feet per minute. At time, t equals 35 minutes. And there is your interpretation. Derivative negative, function decreases, then you just restate the value of the derivative and the time, or the x-coordinate, in this case the t-coordinate, that gave you that value of, in this case, negative 0.72. One more example. Here we have a table of values that represents the rate in wings per minute that a contestant is eating wings at an eating competition. We have values of W given for selected values of t. Use the table to estimate W prime of 10 and then interpret your answer. So we're going to start by getting W prime of 10, and one thing to remember is that a derivative or a rate is always a slope, and in this case, because we only have a table of values, the only way we're going to be able to get a slope is old-fashioned algebra 1. So if I'm going to estimate W prime of 10, the way I like to do that when I have a table of values is, when possible, I'm going to find the slope between the 2 points that sandwich the one I'm interested in. So if I want W prime of 10, that would be approximately, and this is not equals, we're approximating, so make sure you use the approximate symbol, approximately W of 15 minus W of 5 over 15 minus 5. And we will approximate the rate at 10 by using the rate, the average rate from 5 to 15. And then we'll plug the values in there. So that's 10 minus 17, again, over 15 minus 5. And that would give me a rate of negative 7 over 10. And then we have to interpret that. So we have W prime of 10 is approximately negative 7/10. The interpretation, W prime is negative. That means W is decreasing. But then in words, I would describe W. W is the rate that a contestant is eating wings. So my interpretation is the rate a contestant is eating wings is decreasing. Okay, so there is the base interpretation. Derivative negative, function decreases. My function represented the rate that somebody was eating wings, so it is decreasing at a rate of 7/10, because the word decreasing implies the negative rate. So I'm going to say decreasing at 7/10. Now units here, be careful, because W is already measured in wings per minute, and then we found the rate of change of that, so that kind of takes us into an acceleration. So my unit is wings per minute. per minute. We found the rate of change of a rate. So wings per minute, whoa, what's going on here? Per minute, at time, uh-oh, I left out an important word. I just realized a slight error in my interpretation. At time, t equals, and we're using 10 minutes, so I'll put minutes here. And then my slight error in my interpretation is we are doing an approximation here. This is not exactly the rate of change. We don't have enough information to get the exact rate of change. We can only do an approximation, and so I probably need to include the word approximately right here. So is decreasing at approximately 7/10 wings per minute at time t equals 10 minutes. So there's your interpretation. I do want to make 2 points about estimating derivative values when given a table. The first is that when you are doing this, you must write down, if it is a free response question, you absolutely must, on the AP exam, write down this this difference quotient right here. So you must write, that's an R there, write the difference quotient. If you don't, you usually don't get the point. That quotient has an E in it right there. You usually don't get the point for the value of 7/10. So always write down that difference quotient. So that is the first point I wanted to make. The second point is, in these cases, they actually accept 3 different approximation techniques. I prefer to sandwich the point in question when possible. I wanted the slope at 10, so I did the slope from 5 to 15. They also will accept the slope from 10 to 15 and the slope from 15 to, or from 5 to 10. So they would accept any one of those 3 options. I prefer to sandwich it, but it doesn't matter as long as you use one of those 3. And again, you must write down the difference quotient either in the form W15 minus W5 over 15 minus 5, or you could start with 10 minus 17 over 15 minus 5. If you don't write either one of those and you jump straight to the negative 7 over 10, then you don't get the point for approximating the value. They want to see that difference quotient. So there we are with interpreting derivative answers in contexts of problems.